Here we see Ebbinghaus's famous forgetting curve that he generated based on all of his research that he conducted looking at memory for nonsense syllables. Now, basically what this curve is showing you is how much information is retained over several days. So here over on the y-axis, we have the percent retained or accurately remembered and the amount of time going by on the x-axis. Now, the key finding from Ebbinghaus's work was that within one day, over 50% of information learned is lost. Again, this is without retrieval or practice or rehearsal. This is just like this entire set of reading and all of these lecture clips. If you go through all of this today and you don't study it and practice it and maintain it, you will lose over 50% of your memory for it. The same is true in any traditional lecture hall. If you're sitting in a 90-minute long lecture, you'll probably only remember less than 50% of that information a day later unless you actively study it. So we forget a lot of information initially, and then memory loss is not so bad, okay, over time. So another way of putting this is that we have the biggest loss in our retention very soon after learning the material. So decay theory is a prominent theory, and it helps account for memory loss due to the passage of time. One of the problems with this theory, though, is that it it fails to explain why some memories can last so long and others are forgotten so quickly. Now, remember, Ebbinghaus's work is based on remembering those nonsense syllables. And some researchers that were looking at memory were more curious about our memory for more meaningful information. What about information about our own lives or information that's more relevant to us? Again, this theory explains sort of how we forget over time. Okay, but there are a few other theories of forgetting that we're now going to turn to. Okay, we'll look at interference theory, and we'll also look at retrieval theory that add a different set of insights to how forgetting unfolds.